are three objects that we don't have a good definition for. They don't have a definition in words because it's impossible to name them without just using the same word again. But we know what they are. But we agree to with what they are. Well, points. And I just drew 3 points. They're there. We represent points with dots. Represent points with dots, and we tend to name those dots or label them with letters. I chose the first 3 letters of the alphabet because they were the easiest ones, A, B, and C. But however they're chosen, they're just spots. And we'll name them in words with point A or point B. There's not really a symbol for point. It's just the word point. Okay. The second undefined term is a line. A line, well, we kind of know what a line is. It goes on and on forever in both directions. It's straight. It looks like a line. An example of a line could look like this. It could go sideways. It could go out at you, but it's straight. It's called one-dimensional. It has length. That's it. It has no width. It has no depth. It just has length. A line could have, if a line has 1 point on it, like say point X, if it has 1 point on it, then it has to have at least another point. So we can define it, like XY. It has points on it, for sure. We could also give the line a name. We could label this line as something we tend to label in like cursive lowercase letters. Like real creative one is like L. There's another way to label this line. And then to name it in symbols or naming, we could say this is line L, the name we gave it. We could also name the line by any 2 points that are on the line. Are 2 different ways to name the same line. Or 3 in this case. Line L, line XY with the word, or line YX or XY with the symbol of a line over top of it. All indicate the same object. The last undefined thing we're going to look at today is pretty important. It's called a plane. A plane is 2-dimensional. It has length and width. It goes on and on forever in 2 directions. One way we can visualize a plane is if you think of like a piece of paper and then extend that piece of paper on and on, up and down, and left and right. It goes on forever. Think of a plane as like the ceiling that would just keep extending forever and ever, out and out. A plane is defined by 3 points. You have to have 3 points to make up a plane. And 3 very specific points. 3 points that are not all on the same line. They can't be on the same line. Can anyone think of a reason why they can't all be on the same line to define like a specific plane? Okay.
Then it would just be a line.
Well, yeah, if they're on the same line, then you would just you define a line. Any other maybe another like visual reason? Joel?
Because a line has only length. Doesn't have like
To draw and visualize a plane, planes tend to look like a angled piece of paper that you draw on the whiteboard if you want to draw it this way. Planes, as I said, are defined by 3 points that are not all on the same spot, so there got to be 3 points on there. I don't know, how about M, N, and P? are like 3 points that are on this plane. You could also give the plane a name, like we gave the line a name. You could name this like plane,
Z.
Sure, Z, I like the letter Z. This could be like plane Z. Notice Z doesn't have a point on there. Z is outside. It's generally written as a capital letter. And generally, it definitely does not have its own point that's on the plane. And we can name this as plane Z, because I gave it a name, plane Z, or plane ceiling, or plane floor, or plane smiley face, or plane whatever you gave the name to it. Or if you're going to name it, label it by its points, then we need 3 points to name the plane. So we could name this plane, how about M, N, P? What's another name we could give the plane? Plane P and M. Any combination of those 3 points that are not on the same line. Collinear, what's collinear going to up page?
So you know how for like the line.
Points are points that all lie on the same line. If we use the word collinear, that means whatever I'm talking about are all on the same exact line. Same line of thinking, what are coplanar points then?
They're lines on the same, or points on the same plane.
Points
Oh my gosh, I'm so smart.
on the same plane. Okay? Not rocket science, just make sure we're all using the same terminology. If I use collinear or coplanar, we got to know that those mean on the same line or same plane. Okay? A line segment is 2 points and every point between them. That should make sense. We think of a line segment, we think of a chunk of a line, a segment of a line, or a part of a line. 2 points and all the points between them. How about R and S? 2 points and every point in between them. There could be more points. Maybe this is just, literally is just a chunk of a line. So maybe it keeps going past R and keeps going past S in the other direction. The line segment only talks about the endpoints and the things in between. We can name this as segment RS, or maybe using a little more concise would be RS with a line segment drawn above it. RS with a line segment drawn above it would tell us that's segment RS. Since we only need the 2 endpoints, what would be another name for this segment? You also call it segment SR. As long as you use the 2 endpoints to name a segment, you're fine. It has to be the 2 endpoints. Similarly with array. Array is a point on a line and all of the points on one side of the line. Naming array, you have to be very, very careful. For a line and a line segment, you can interchange which letter you go first, because you just have 2 endpoints, or you just have any 2 points on the line. An array, there's a very specific convention. We always, always, always start naming array with the endpoint. The endpoint being the point that doesn't go any farther. The endpoint or starting point, however you want to think of it. It's the point that defines the array. In this case, array L, and then whatever other points are in the same direction we want to go. In this case, it could be Q. Start at L and go toward Q. If there's another point in here, how about like
T.
T Sure. Right, ray LQ is the exact same ray as LT because we start at L and go in toward T, which is the same as starting L and going toward Q. But the key is that the first letter has to start. The letter that begins the ray has to start. L has to be the first name, the first letter in this ray, then any other point in the same direction we want it to go.
You only put 2 letters.
And you only use 2. The first point, and then any other point that goes in the direction you want it to. LQ, LT. You could call this LT with a ray above it. A ray having 1 arrowhead. Opposite rays are 2 rays. Rays with the same endpoint. That also form a line. Say an intersection is anywhere 2 objects share a point. It's the last definition. We'll talk through this example in just a second. We don't have to jot this down. But the last thing, in intersection, be aware, anytime something shares a point or more, those things are said to intersect. So if a line crosses, they share a point. At that cross, that's called the intersection, and they have to intersect.
Slide it down.